Okay, so welcome. If this is your first time, welcome to Cloud Native Madison. If everybody could please make sure to have your microphones muted while we're giving the talks today, that'd be much appreciated. My name is Brandon Tim. I'm one of the co-organizers of Cloud Native Madison, along with Kurt Rakely. You can see our Twitter handles there, and if you ever want to reach out about a topic or a talk or really anything that you might like to see in the meetup, go ahead and reach out on meetup.com or Twitter or however you can get a hold of us. Real quick, just a little bit of meetup business. So we are going to hold our next online meetup next month on November 5th. We don't have a topic nailed down yet, but we are in talks to hopefully have a talk about chaos engineering in the cloud native space, which is something that we have not yet touched on in our meetup group. So really looking forward to hoping that talk shapes up and have some new interesting content for everybody for next month. Our sponsor this month is Solo.io. For those not familiar, Solo.io is really involved in sort of anything involving the virtual networking space with modern cloud-based architectures. They do tons of stuff with Envoy, which is obviously what we're here to talk about today. If you'd like to learn more about their company, you can see their website there, or you can go ahead and just reach out to them on their Slack channel if you want to learn more about what Solo.io is doing. With that, I would like to have everybody give a warm welcome to Lawrence Gadban. He's an engineer at Solo.io, and he's going to be talking about basically all the different applications of Envoy in the world today. So with that, take it away, Lawrence.
All right, thank you. Let me share my screen. Okay, can you see that all right?
Looks good.
Okay, so all right, let me go. Okay, so I'm Lawrence Gadban. I'll be giving a talk today on, it's called Envoy from the Edge to Service Mesh and Beyond. And so really what we'll talk about is kind of the role that Envoy plays when you're looking at service mesh, or if you're talking about an edge gateway, and the various places that Envoy can fit in, and how Envoy helps when you're trying to use these type of patterns. And so we mentioned Solo.io. That's where I'm a field engineer at Solo.io. We are the modern API infrastructure company, and basically, like Brandon mentioned, we are heavily based on Envoy proxy, and we'll talk about Envoy a whole lot in this talk. On the left, you can see a few of our products. So we have Glue, which is a gateway that we will briefly touch on today. Service Mesh Hub, which is basically a multi-cluster service mesh tool, and then WebAssembly Hub, which is a way to, as WebAssembly becomes more and more common, and we'll talk about this as well, how can you manage your WebAssembly modules and so on. So I'm Lawrence Gadban, field engineer. Been at Solo for about 7 or 8 months now. So working in the field directly with customers and users and how they've been using our products and how we can help. So seeing a lot of interesting trends and a lot of interesting things. And prior to that, I spent about 8.5 years at a company called USAA. They're a pretty large financial services company. While I was there, I spent about 5 years being primarily a developer. And so working, I did some Java, I did some JavaScript, some Golang. And then the last three or so years I was there, I was primarily focused on kind of the cloud native journey that they were going under. So, managing OpenShift clusters, then also kind of working on API security. So things like API gateways and service meshes were coming into play as well. So let's go ahead and get into the actual content. So one of the things that we see, and I think a lot of organizations are kind of going through this, is the journey from a monolith to microservice-based architecture. And this is a huge topic. There's been tons of talks about are microservices right for you and et cetera. But we do see quite a few folks that are going through this kind of journey. And what that ultimately means, right, is you have an existing legacy style setup where you have a monolith and you want to break that up into smaller components. And so there are technical reasons why this makes a lot of sense. The easy one to think about is when you have a monolith, if you need to make a change to a component, some functionality in that monolith, you need to build and deploy that entire unit. And that becomes, there's a lot of risk involved with that. And if something goes wrong, you need to roll back the whole thing. So if you can find a way to break out that functionality, you get a benefit in that you're reducing kind of the risk of making a change. You can hopefully, move faster. And there are other valid technical reasons why this kind of migration makes sense. Besides that, there's also organizational benefits to doing something like this. And most large organizations, enterprises, they will have, you'll have teams that are responsible for components. So like you have an accounts team or a billing team or something. And those, the logical way of writing your software is to match those units of organization. Whether or not that's a good thing can be debated as well, but it's definitely something that's common. And so microservices are a nice fit for when you have, groups of services that are owned by specific teams. And if the functionality is owned by that team, and if they own kind of the deployment unit, now they can iterate as fast as they want. Their velocity is under their control. They can also do things like choose their languages that they use. And so there are other benefits. It's not just technical. There's organizational reasons why this makes a lot of sense. But when you do this, you introduce new challenges. For example, let's say you have like 20 separate components in your monolith. When you break those up into microservices, now you have 20 different, services. And, are all of those services expected to be called by everybody else? Or are you going to expose some of that functionality as an API, an externally facing API that then behind the scenes will be called or call, separate microservices? And basically you have to figure out, how do I manage all of those APIs and all of those services? Then there's the question of security. How do you enforce security? So before, if you had everything that lived in a monolith, you had the benefit of knowing that you were making, basically an in-process call to get some other functionality. Now that that's broken up, you have to worry about, okay, this is going to be a network hop. This is potentially going to be in a cloud. And, I have to worry about, I cannot trust that I'm running in a safe environment, or that this service is running over a secure environment. So now I have to introduce security at all of those different places. And then finally, you need to worry about observability. So before, you had a request being processed by your monolith, and that was all happening in the same thing. You could go to the logs and you could see the flow. But when you have all of these discrete services, now you have to worry about troubleshooting that. You have to know, okay, which service called what? Do these logs correspond to the same logs in this other service A and service B and service C and so on? So hopefully you have some sort of correlation ID, and it becomes challenging to know what's actually happening in your system. And then to throw onto that, these potentially, one of the things that's happening is you may even be working with multiple clouds. And so, these are public clouds being called out here, but they also could be, you could have an on-premises legacy infrastructure, an on-premises cloud. And so you have a bunch of different environments in play. And so when you're talking microservices and distributed architecture, these challenges, you will run into these challenges. So one of the patterns that's coming into, it's been popular for a while now, and it's starting to become really, we're starting to see folks that are really getting serious about service mesh. Service mesh is a pattern that helps with some of these challenges. So I'm sure, many of you guys are familiar with service mesh, but just to briefly talk through it, the essential, what you're really doing with a service mesh is you have all of these discrete services, and those services are basically represented as, workloads. We'll talk in Kubernetes. You have a service and you have deployment. So you have multiple pods that represent your workload. And what you can do is you can push a proxy that lives alongside that your workload. And so in the same pod, you'll have, let's say, two containers. You'll have a container that represents the workload, and you have a container that contains the sidecar proxy, right? It's the sidecar pattern. And so when you do that, what you're doing is you're offloading all of the network responsibility of the service communication to the proxy. So the application will make a request to service B, but it's ultimately that sidecar proxy that's going to make the request to service B. And then on service B side, on the service B side, the request is being handled by that proxy that lives inside the service B pod. And so you get a lot of benefit by doing this because it helps with all of those concerns that we were just talking about. In order for this to work, though, you need what is called a control plane, because the proxies inherently are going to need some configuration, and they're going to need to know, okay, so let's try this. So if I have if I have service A, right, and I want to talk, or service, let's call this service A. I have service A and I want to talk to service B. This request is happening. This proxy needs to know, how do I get to service B? Because in reality, the service B is probably going to be made up of more than one replica, right? In a real world environment, you're not going to be running a single workload. You're going to have multiple of these. And so this proxy needs to know where all of where all of the replicas for service B live. And so that's where the control plane comes into play, because the control plane can, one, if we're talking Kubernetes, watch Kubernetes to understand the state of the environment, take that information, translate it into what the proxy can understand, and send that information to it dynamically. In the case of this example, again, we're using Envoy as a proxy, and we're going to be talking about Envoy a lot. This is kind of the de facto standard for service mesh. There are other ones, but Envoy is pretty popular right now, and for valid reasons. And we'll be talking through a lot of this. So that being said, when you take kind of the bigger picture of what this actually looks like, right? You have a bunch of services that live in your cluster. So in this bit, let's just say this is a Kubernetes cluster. In this case, you have 5 services with your sidecar proxies talking to each other in the mesh. But then you also have a north-south component to it, right? So if we're calling east-west traffic within the cluster, within the mesh, there still is a north-south component to this, because traffic needs to get into this mesh somehow. And so that's where the edge kind of comes into play. And in Istio, for example, you can also have an egress proxy. So, but the concerns there are at the edge, right? And that's a different set of concerns than what's happening inside of the mesh. So a mesh is great. It's becoming very popular. Some of it's hype, some of it's reality, but this is a real thing, and there's a lot of value in a service mesh. We think that most enterprise organizations, or as you grow in a cloud native world, as you grow in a microservice world, there are absolute reasons why a service mesh is useful. But it's not something that you want to just run into blindly. And so there are things that you have to consider when you're talking about adopting a service mesh, or thinking about getting to a service mesh. And so let's go through some of those. So the first question really is, do you even need a service mesh? Because again, service mesh has become it's definitely become a very popular thing. And folks are trying to use it maybe when they don't need it or not yet. And so you need to ask yourself, do I even need to use a service mesh right now? And so some of the questions that you can ask yourself as you're going through that decision are, do you have a mix of application languages or frameworks? This is an important question, because when you're in a smaller organization or a smaller environment, some of the stuff that we're talking about in the service mesh. So one of the examples of what a service mesh provides are things like fault tolerance, right? So as you're talking distributed architecture, you're making a bunch of network calls, requests are going to fail. That's going to happen. And so one of the ways that you can solve that, and maybe this is kind of a Band-Aid, but in a lot of times it makes sense, is just to retry the request. So if you got a connect failure, or if you had a connect timeout, or if you had something else happen to where your request failed, a lot of times a retry will be helpful. And so you want to add a retry into that flow. And so if all of the services in your organization are implemented with the same language or framework, that's something that you can build into your app, right? You can build that into the application layer. And if you look at some of the older, not older, but some of the relatively older technologies, like in the Java world, right? There was Hystrix by Netflix. There's Resilience4j. There are other tools that build this kind of stuff into the app. And so you're instrumenting your application with this tool that can perform fault tolerance type of functionality. That doesn't work as well if you're in an environment that has multiple languages or frameworks. And in that case, so let's say you have an infrastructure team that owns whatever library you want your apps to use. If now you're saying that team is responsible for implementing a fault tolerance library in 8 different languages, it's quickly going to get out of control. And so in that case, maybe a service mesh can help, because you're pushing those concerns out of the application and into the network tier, or really, you're using the mesh and the sidecar proxy to add functionality without having to build it into the app. Another question to ask is, do you have a large amount of microservices? If you only have 10 services in your entire organization, the complexity of a service mesh will probably outweigh the benefits of using it. And because a service mesh is not a light thing, right? You're putting proxies at every service, and you're you're changing the network path for every single service call. So it's not something that you want to just rush into, especially if you only have 10 or so services that are not going, and you don't see potential for growing that. Another question is, do you actually have a lot of service-to-service communication, a lot of east-west? Because if you say, okay, so let's say you're building a single page application and you have 10 APIs that you call, but those 10 APIs are kind of standalone, right? So you call one of them and it's a self-contained unit, and then the response goes back to the single page app. There's no real benefit for a service mesh because there's nothing that you need to do when you're making that API call. You just make the call, the API processes it and sends the response back. If there's no east-west communication happening, there's no reason to use a service mesh. So then the next one is, are you struggling to implement application network observability? This is one where, if you have a solution for, making 20 different service calls in a single request, if you have a way of understanding that flow, then maybe you don't need to use a service mesh. If that's already something that's comfortable to you in your organization, then maybe you don't need it. One of the big values of the service mesh is that it pushes, or I guess it makes observability kind of table stakes, because you get that for free at the proxy layer. But if you don't need that, maybe you don't need a service mesh at all. And then finally, are you comfortable with your infrastructure stack? And the reason that this is important, so we'll talk Kubernetes. A service mesh is a pretty complicated piece of tooling, right? And Kubernetes itself is complicated. So if you're not really comfortable with Kubernetes and your SREs or whatever you're using to ensure the availability of your system, if Kubernetes is still challenging, or Kubernetes is still, if you're not quite there yet, throwing a service mesh into that is really only going to exacerbate that problem. So you need to be comfortable with the infrastructure you're running on before you start considering a service mesh. Okay, so let's say you decide that you do need a service mesh. There are challenges as you start going through that service mesh journey that you'll need to think through. These are things that you'll have to decide as you go through it. So the first one is really, which one do you choose? So there are, quite a few service meshes now. Istio, I would say, is probably by far the most popular. But Istio isn't the only answer. And so when you're talking service mesh, there's also considerations for which environment you're running in. So for example, if you're running in AWS, app mesh is a very viable solution, right? That's a native thing to your environment. Microsoft just released Open Service Mesh, OSM. And then there's Linkerd, which actually was one of the first service meshes. So choosing the right one can be a challenge. You have to make sure you don't want to pick the wrong one and start building out all this tooling around it. And then also, like we talked about, a service mesh is a complex thing. Picking a service mesh and then putting all this investment in it and then deciding that, this maybe wasn't the right choice. That's not really a situation that you want to be in. So then another question is, who's going to support it? And this is more along the lines of like enterprise support. Some Kubernetes distributions may come with some sort of Istio offering that you can use. OpenShift has one. But if you're going to use something like this in a production environment, more than likely you're going to want support. And that's an important decision, because if you don't have that, and if you're not comfortable with the service mesh, if something goes wrong, you're going to be in a tough spot. Just as a side note, we at Solar are actually offering enterprise Istio support, so just something to consider there. So then another question is the multi-tenancy issues within a cluster. So if you are running a Kubernetes cluster, and if you are, if you have a multi-tenant environment, that can become a challenge with service mesh, because then you have to decide, okay, do I want a single mesh for all of these tenants, or does each one of these tenants get its own mesh? And if so, how am I going to manage that? That's not something that's really trivial to do. And along those same line is managing multiple clusters. So in a lot of circumstances, right, you want to, you have multiple clusters, and whether this is for domain, kind of breaking up domains. So you have, one line of business that has its own cluster, and then a different line of business has a different cluster. Or if you have just multiple replicas of your environment for HA reasons. So if you have, a multi-region deployment where you have mirrored environments in both of those regions, how do you solve the service mesh in that circumstance? So Istio has, you can do things like a shared control plane for two meshes, or you can have a replicated control plane. But that's something that you'll want to, that's not an easy thing to do. So you'll need to consider what does your cluster deployment look like as you're building out your service mesh. The next one, fitting with existing services. This one is actually something that's really improving over time. But the point here is that it's not completely transparent to run an application in a mesh. And so things like the sidecar lifecycle come into play. Up until recently, sidecar was really just kind of a convention. You just threw another container in your pod, but there's no controlling of the ordering and stuff. You could use an init container, but that's only for the container that starts and stops before the rest of your containers run. So that is something that's improving, because now there is a life cycle being built into Kubernetes that helps with this. Race conditions is another similar thing that's improving. But for example, say you have a workload that you want to run in your mesh, and that workload is, let's say it's a job, right? So you want it to start and then stop. If you're running that and you need to talk to services in the mesh, you need the sidecar proxy. But the sidecar proxy doesn't really care about your life cycle, or the proxy. That would mean that the proxy needs to start up before your container, your job, and then once your job is finished, then the proxy needs to shut down. And it's just, you have to manage all of that. The next one, delineation between developers and operations. So a lot of the concerns of the service mesh are, they kind of straddle the line of development versus ops or DevOps or whatever. So you have to figure out, how am I going to manage, who's going to own the various configurations? So who's going to own the fault tolerance config? Who's going to own the security config? Who's going to own the load balancing configs and all of that? So those are things that you need to figure out as you're going through the service mesh adoption journey. And then lastly, what about legacy and hybrid environments? This is important because, in most places, you're not operating completely greenfield. So you have, a set of legacy infrastructure that lives on-prem, and now you're finally going to the cloud and you're trying to go greenfield with microservices. How do you bridge those two? If you decide to go service mesh in the new world, what do you do about the old world? And so that's another thing that you'll have to consider as you go through kind of that journey. So with all of that being said, one of the things that you also want to consider is this is kind of silly, but it is a real thing where, what we call the Death Star architecture. And, when you're getting into service mesh, if you have, 100 services in your service mesh, if every single one of those services can talk to each other, now you're looking at potential for the call graph exploding and looking like something like this, where it's really hard to reason about which services can talk to which other services. And since every service can talk to each other, it becomes this giant mess. So you definitely want to avoid that as you start to grow your deployment, as you start to scale out your service mesh deployment. It's something that you need to consider. So how do we keep all of those considerations and challenges? Well, what can we do to help along that path? And so at Solo, one of the patterns that we've seen successful and we kind of recommend is starting with a gateway approach. And so starting very simple, starting at the edge with a single proxy. And so going back to the example of you have a legacy on-premises environment, you're moving to a cloud environment for microservice-based stuff. You can use a single proxy that will help you, okay, we're going to deploy 5 microservices to start. This is our first iteration. And you can use a gateway there that will front those microservices, and then you can start growing from there, right? So, down here, we call something that lets you iteratively adopt service mesh. That's ultimately the goal, right? Is use a gateway, get some services running, get the interactions right. You can figure out your security posture, figure out how you're going to, deploy the infrastructure. So right here, we call it, understand the necessary infrastructure. When you're talking cloud and when you're talking kind of, declarative style configuration, this is where things like your CI/CD pipeline comes into play, right? So with Istio, you have a set of declarative configs, a virtual service, et cetera. Those are things that, GitOps is becoming more and more popular for valid reason. And so if you want to use that style of deployment, you need to get your configuration. You need to get that infrastructure in place for that to work correctly. And so, for example, you have an application, you have a repo for an application, and then you have a configuration repo that contains the Kubernetes manifest, the Istio manifest, right? And you need to figure out how you're going to deploy all that. If you pick a gateway that also follows those same patterns, it allows you to get those patterns in place for your infrastructure and grow with your infrastructure while still not having to jump all into the service mesh type of model. One of the other things that's really important that we say, you know, the data plane is important. So if you're going to pick a gateway to help you on this journey, you want to pick the data plane that matches what you're going to more than likely pick for your service mesh. And obviously what I'm getting at is that most of the service meshes, you know, other than Linkerd, we kind of talked about a few of them, most of the service meshes are built on Envoy. And so if you're going to go the gateway approach to help bridge that gap, it makes sense to pick something like Envoy for your gateway. And so why would you want to do something like that? You know, so basically the answer to all of those, you know, those questions from before. So a gateway gives you flexibility is really, I think, the main point that I'm trying to make. A gateway is, it's a lightweight unit that you can use to compose your architecture based off of the needs of, you know, as you grow, you're going to see things that you didn't expect, right? And if you have gateways that you can kind of, you know, put in the place of your deployment, it helps you augment and complement existing infrastructure. It helps you, you know, iterate on what you have defined for your new stuff. And then, you know, ultimately, if you need it, once you're done with your old infrastructure, if that ever happens, you can cut it off with gateways, right? And it's basically they're units that you can use to help kind of control that flow of traffic. And you know, when we're talking using, let's say you use an Envoy-based edge proxy or gateway, you get all of the benefits of Envoy. So you get, and we'll get more into this later, but you know, you can easily do canaries, right? You can easily do retries and all the stuff we talked about. And using Envoy at the edge also means that when you start using Envoy in the service mesh, you're already used to these concepts. You already know how to do all this stuff. And it really helps with kind of that progressive iteration. So, and then security posture, that improving the security posture, that's one of those things where using gateways is kind of like a plug for different locations. You can put enforcement points where they make sense. So as you're going through kind of this journey of, okay, on-prem legacy, cloud, you know, microservices, as we go through this journey, we want to put an enforcement point, you know, in one location, because that's where we want to start enforcing OAuth, or that's where we want to start using JOTs for everything. And it gives you a composable way of doing that. So when you're talking the edge and when you're talking service mesh, we talked about this earlier, you know, there's a different set of concerns that you need to care about inside of the mesh, east-west versus at the edge, north-south. And so again, you know, when we're talking north-south, again, this is kind of, you know, what the topology looks like, right? So you have these services in a cluster. This can, or, you know, maybe it isn't a service mesh yet, but the service interactions between these are it's a different set of, you have a different set of concerns versus what's at the edge. And the edge, really, it's whatever kind of boundary, whatever logical unit you've defined as the edge. And that's kind of what I was saying with the gateway is it allows you to be flexible on how you make those boundaries, you know, whatever context you're defining. The easiest way to look at it would be a Kubernetes cluster. And, you know, these are the workloads in the Kubernetes cluster, and then this is your edge, so your ingress in the general sense, right? So if you use you're talking about north-south traffic ingressing into your boundary. And so when you're talking in conjunction with the service mesh, let's take a look at like kind of what concerns you have that apply in both cases. So traffic control and routing, you know, pretty basic. You know, you need to be able to route correctly, and you want to route correctly based on, you know, host and path and headers and all that kind of HTTP stuff, or whatever else it is. You know, that's pretty much, you're going to do that in the mesh, you're going to do that at the edge. TLS and MTLS, they're both important. They're important in both places. This is actually an interesting one because when you're thinking of a mesh, you know, one of the main value adds that Istio provides is kind of the automatic MTLS support. And so that allows you to, since you have proxies that are being enforced that they get injected into your workloads pods, now you can do things like, okay, I want to have service identity to determine authorization rules. So you're not only encrypting your network traffic, but you also have a way of saying that, okay, service A can talk to service B, and I'm going to enforce that by the service level, but service A cannot talk to service B. At the edge, the concern is still there for TLS especially, but it's a little bit different because when you're talking edge, like if you go back to here, right, if this is a Kubernetes cluster and this is your application, at this edge, you really want to present your real, you know, your application cert, your like, you know, example.com, right? You want to serve that up from here. But inside of the mesh, usually you're going to be using some sort of CA, like if you use Istio, the default way is it uses its own CA. those certs are fundamentally different, right? So the concerns are the MTLS and TLS concerns are there, but they're a little different whether you're talking about the edge or the mesh. Observability, we've talked about that already. You know, that's a very important thing when you're talking you know, microservices and multiple service interactions. Observability becomes increasingly important because, you know, from personal experience, you know, trying to troubleshoot distributed applications that don't have good observability is a nightmare because you don't have anything to tell you. You know, you're basically looking for a needle in a haystack, and that's where if you have it implemented correctly, your edge gateway and your service mesh all participate in the same trace. You have like some sort of correlation ID. Envoy has a nice way of solving that, and you can actually you can track the request as it flows through your 20 different service calls. And policy enforcement, going back to security, you know, you're going to need to do security. You're going to need to do it at the edge. You're going to do it inside the mesh. There's no getting around that, especially as you're talking cloud environments. You know, hold the whole zero trust network and everything. That you know, that's basically you have to do that. So then, if you talk about north south versus east west. There are also some things that you don't really necessarily care about, or you don't care about as much inside of the mesh versus at the edge of your boundary. And you know, a common one is OAuth or OIDC. More specifically, OIDC. You know, OpenID Connect, right? That's really the authentication tool for let's say a web browser-based application. So you know, you have a user that's logging in with their credentials, and you're talking to some auth server. And they're logging in the browser, and they get, you know, you have an ID token that represents the identity of the user. That's more of an end user concern. That's not really something that happens inside of the mesh. It could, but it's not as common, right? So that's something that you want to enforce and take care of at the edge. Web application firewalling, you know, WAF. That's another one of those things that usually has to do with as untrusted user interaction flows in and out of your system, right? You could have a WAF on every hop inside of a mesh, but more than likely, it's not something that you would want to do. Message transformation. This has to do with the whole kind of, you know, a lot of the value at the edge, and especially if you're talking like the API gateway model, you're kind of exposing an API that is, you know, not necessarily tied one-to-one with the internals of your system. So you're publishing an API, you're publishing a contract that you want people to interact with, but you're not telling them that this is the internal of my system. You're saying, use this API, and then behind the scenes, I'm going to do whatever I want. So if that's the case, you know, you may need to perform some transformation on the data that you're getting in. You may need to transform the request, the shape of the request, to match the internals, and you can do that at the edge. And then rate limiting, you know, you may have kind of edge-specific security like HMAC, and then the API service into coupling kind of goes along with the message transformation. So enter Envoy as the gateway, and this is kind of the whole thing, right? So Envoy is a pretty fantastic piece of software, CNCF graduated project. Kind of, again, it's kind of blown up in popularity for a lot of valid reasons. And so if you use that at the gateway and at the mesh, you get a lot of benefits. And so why Envoy? You know, here's a laundry list of things that Envoy does. A lot of this stuff other proxies do. The one that I want to talk about a lot is the first-class dynamic configuration. And the reason for that is when we're talking this distributed architecture cloud, you know, all that stuff, you know, pods are mortal, I think is how the Kubernetes documentation references it. So you're going to have pods that die. You know, you're going to have pods, you're going to have nodes that scale in and out. You're going to have pods that move around for maintenance and on those nodes, et cetera. And basically, you know, everything is dynamic in that environment. And so you need a proxy that can handle that. And so when you think of some of the older proxies that, again, you know, they're good tools and they definitely have their place, but a lot of those tools were built, a lot of those proxies were built to be statically configured. So you have, you know, some configuration file that tells the proxy, you know, these are the endpoints, and, you know, this is how I want you to do the routing rules and everything. And that's great. And then if you ever need to change it, you need to change that static config, and you need to reload the process. And, you know, and there are cool things you can do, like, okay, we'll do a hot reload where we'll transfer the open sockets to the new process that it spins up and all this stuff. But that's all working around the fact that you have to statically configure the proxy. So when you're talking dynamic configuration, you know, HA Proxy, Nginx, these are tools that have been around for a while, but they're adding dynamic configuration, but they're doing it because, you know, in the modern kind of cloud world, you have to be dynamic. There's no getting around it. And so Envoy itself, you know, that's kind of, it's first class, right? Envoy was designed for these use cases. So the dynamic configuration is kind of inherent in it. And it's really important. So like some of the other ones, I think that like they're mainly using HTTP. With Envoy, you can do dynamic configuration over gRPC, so it's very efficient. And the API was designed from the ground up to handle that. So Envoy makes a lot of sense for this kind of environment. And then to kind of briefly look at like the logical order of what this could look like. In this case, you have Envoy sitting as a proxy between a client or another service to whatever you define to be behind your edge or behind your gateway. So maybe you want to route to your monolithic legacy infrastructure, and then service A, which is over gRPC, and then a WebSocket call to service B. But you also want to do a canary to service B prime, and you have 5% going to this new version or whatever. And so this makes sense. But then you can even do something like throw the API decoupling in front of it. So now you have an API that you're exposing that isn't mapping one-to-one to what's happening behind the scenes. So like, for example, this gRPC call, you could expose that as a JSON REST endpoint here, but behind the scenes, you're actually making a gRPC call to service A. And so, there's a lot of power here. And so that's kind of what Glue is. So Glue is an API gateway that's built on top of Envoy. Ultimately, Glue is the control plane and Envoy is the data plane. And Envoy is built on some filters. What it does is it provides a way for you to dynamically configure Envoy, but you don't have to build your own control plane. You can use a control plane that's already built for you. And then, it runs anywhere. It can use a lot of different kind of config, but for example, Kubernetes, the most common. And like most Kubernetes apps, you can configure it with custom resources. And so Glue will watch those custom resources in your Kubernetes environment, translate that to the format that Envoy understands, and stream that over the XDS API, which is how you dynamically configure Envoy, to set up, okay, these are the filters that we want to have on a given request. So actually, I'm looking at the time. I want to definitely have some time for that. So I'm going to go a little faster here. Basically, Glue can, Glue adds the functionality that we were talking about at the edge, and it's one of the ways that you can accomplish some of this stuff. So let's see here, and then patterns. I'm going to skip through this. Ultimately, what we're trying to show here is that, if you start off small, having a single edge gateway will help. You don't even have to have service mesh yet. You can have, however many services, your microservices, use a gateway to front them. And then as you grow, you can start using additional gateways or edge proxies. You'll start defining your edge at different layers based off of how your deployment's growing. And then when you throw service mesh into it, right, it may look something like this, where you have multiple service meshes that have inter service east-west traffic, but then you're jumping out to different API gateways that live at different points, which help prevent that Death Star architecture, because every single service isn't going to talk to every single other service. You have these nice points, these decoupling points, where a service in mesh 1 can talk to another service in mesh 2. And then ultimately looking to the future, as your deployment grows and you have more meshes, as you have more gateways, you're going to want tools that help with that, because that can quickly go out of proportion. And that's where tools like Service Mesh Hub or Glue Federation help, or even some of the other open source tools like KubeFed, can help federate amongst clusters, and basically something to consider. And then finally, WebAssembly is kind of the future of Envoy proxy. And so if you want to configure Envoy today, what you need to do is you need to write an Envoy filter written in C++, and you need to build that into the Envoy binary. So you need to build Envoy yourself. You need to add your filter into that build process, and then you get a binary that contains your filter with your custom code in it. WebAssembly is going to change that, and it's going to give you a way to basically write an Envoy filter in, soon any language. Today, there's a subset of language that can compile to the WebAssembly that Envoy expects. But like, for example, you could use Rust. And if you use Rust, then you can compile it. You can write a filter, an Envoy filter in Rust, get a WebAssembly module, and then dynamically load that into Envoy to customize the behavior. And this is, I'm rushing through this, but this is really, really exciting and powerful, because it gives you the flexibility to dynamically configure Envoy. So if you have Envoy in the mesh, and if you have Envoy at the edge, and you can deploy those in different places and kind of compose your architecture, you now can also deploy custom logic at each one of those points. So it becomes very powerful and very flexible for whatever you want to do with your traffic. And so with all of that being said, let's get into a demo. And so what I initially was going to demo was kind of, Glue interfacing with service mesh. And so, using Glue as the gateway and Istio as the mesh. But I think it's actually more beneficial to kind of talk through what Envoy is actually doing under the covers. And so why Envoy is so great for this job. So I'm going to go ahead and, okay, so I have a terminal here. I hope that that's big enough. If not, someone please tell me. And so what we'll look at is I want to show what an Envoy configuration looks like from kind of the static configuration. So, no control plane, let's just configure Envoy, and let's use Envoy to do some proxying. So I have a Kind cluster running on my laptop right now. And in that cluster, I have 2 pods. I have a pet store, which is my sample app, just serves up some JSON. And then I have an Envoy pod. So this pod is, it's running a single container that has Envoy in it, and then a single configuration file. And so let's take a brief look at that config file. Ignore the name. This is based off of the example, one of the examples that comes with Envoy. Actually, you know what? Let's do this. Okay, so this is my static config file built into my image. And so we'll go through this really quickly to show, how this is set up. So the first thing we have is an admin section, and this is really defining the admin interface for Envoy. And we're going to use this to kind of explore what's happening inside of Envoy. And basically, I'm just saying that, okay, the admin interface is going to be available at localhost port 10,001. So then I get into the actual configuration of what I want my proxy to do. Since it's all static, it's under the static resources section. The first thing I do is set up a listener. And this listener really translates to a port, essentially, right? So Envoy is going to listen to any address at port 10,000, and it's going to be expecting a TCP connection. So when I'm making a HTTP call, I'm using HTTP, we'll be using HTTP, I'm going to hit my pod's IP, or basically I'm going to hit my pod at port 10,000 and send my HTTP GET request or whatever it is. Then what we do is we assign a filter chain, and this is where all of the processing happens. In this case, there's only one real filter, and that's because this is the HTTP connection manager. So this is a network filter. You can see that here. And the network filter is kind of the lower level filter for Envoy. And in the case of, so we were talking about connections and TCP connections. What the HTTP connection manager is responsible for is taking care of the HTTP part of it. So ultimately, right, you're shifting some bytes around over TCP. You need something that will translate that into HTTP concepts, right? So, things like headers and the path and the request body and all that stuff. And that's kind of this network filter's job, the HTTP connection manager. And so then we start configuring it. One of the important pieces of configuration for it is the route table. So in this case, I'm defining a route, a single route that is called local service. It's going to any domain because of the star domain. And so this means the host header of the request. If it is anything, this virtual host will handle it. So basically anything will be handled by this virtual host. And then inside of that, we have a single route configured, which is that so then I'm setting up a matcher. I'm saying a prefix. So this is a path prefix of /, which is another way of saying basically any request, right? Because every request has a root. It's the root, /. And then what I want to do is I want to route to a cluster that's called pet store. And then, so we'll get to that in a second. And then as another configuration on this connection manager, I'm defining a set of HTTP filters. So again, the HTTP connection manager is a network filter, kind of the lower level, but then there's also the concept of HTTP filters, which are what actually, they operate at the HTTP layer. And so in this case, I only have one, which is the router, and that's what's actually responsible for taking the HTTP request, inspecting it, based off the route table, taking that request and forwarding it to the correct upstream destination. And so then I mentioned the cluster. In this case, this is my cluster definition. A cluster is really, what endpoint or what destination I want to go to. And the important part here is that I'm defining a cluster that goes to the address of pet store and port 8080. And so how this works is that, again, I'm running in a Kubernetes cluster, right? And so if I go back to my terminal, let's do this. If I go back to my terminal, what I can do is if I get my services, you'll see that I have a pet store service defined that listens on port 8080. So what's going to happen is that Envoy is going to say, okay, I'm going to do a DNS resolution of pet store. And in the sense it's running, inside of the same namespace, it knows that, okay, this pet store corresponds to this 10.108.223.120 IP. And so what I'll do now, I have my Envoy pod running. I'm going to port forward to that, port 10,000 again, so we can see the actual request. Okay, so that's there. And then if I curl to localhost 10,000 /API/pets, I get my response from my pet store application. And so what happened is that I made a request to the listener here, right? This listener, which has HTTP set up. And then the HTTP request was inspected. It had, there was no host headers set. So this works fine. And then the slash prefix matches because I sent for /API/pets. And so it routed that request to my pet store service. And so what we'll do now, I want to look at the admin interface. So then let me open up the browser. And then if I go to localhost 10,001, so this is the admin interface that I was talking about. And then what I can do is I can go to my clusters here. Let me make this a little bigger. So this is the cluster definitions for my Envoy instance. And in here, you'll see that, okay, so I have pet store, right? And again, for pet store, we defined it to be the pet store DNS name. And that we saw that the IP address for that pet store service is 10.108.223.120, right? And so you have that defined here. So this pet store cluster has a single endpoint that corresponds to the cluster IP of my service. And so that's how kind of the routing takes place. But ultimately behind the scenes, this is a service IP, which means that really kube proxy is taking over. And so if I scale up, let's scale up my deployment. We'll scale it up to 2, right? And so now I have another pod. Okay, so that's running. If I refresh this though, nothing changes because it's still pointing just to the service IP address, right? The fact that there's a new pod is not important because I'm using the service IP. And that is actually not a great thing because what it means is that, some connections are going to be established to this service IP, which means that as I scale up, unless those connections are reestablished, they're going to be going to the initial pod. So, there are concerns there, and we're not actually, we can't actually do things like canary releases or anything because we can't target individual pods. And that's where the control plane comes into play. So not only do you need a control plane that can, you want to be able to update this dynamically, but you also need it to be something that can, understand Kubernetes and give the correct IP addresses to your environment. So really quickly, let's go ahead and look at using Glue for that, or pretty much any control plane. Any control plane that's Kubernetes aware can do this. And so I have Glue installed. So we'll do deploy in the Glue system namespace. And this is a pretty slimmed down, this is just the open source version of Glue. So I have this gateway proxy, which is the actual Envoy pod. I have Glue, which is my control plane, and then some other stuff, which I'll skip for now. But ultimately, what I have now is I have Glue listening on port 8080. So if I were to do this and go 8080/API/pets, it will work as well. And so the reason that this works is that I have so Glue will look for Kubernetes style configuration. That's called a virtual service, very similar to what Istio uses. But if I look at my virtual services, I have a pet store one. And if you look at what that actually looks like, it should look familiar because this is really kind of the abstraction that we use in Kubernetes for configuring Envoy. So we have a virtual host, a domain, a route, matchers, etc. And so, ultimately behind the scenes, what we're doing is we're telling Envoy, hey, I'm configuring Envoy through a Kubernetes CRD, and I want to say go to an upstream, which corresponds to that service that we were just talking about, my pet store service. But really briefly, what I'll do now is if I go, I'm going to port forward to, in the Glue system namespace, my gateway, my Envoy instance there, which is called gateway proxy something. And then I'll go to port 19,000, which is the admin interface for that one. When I go to check what's there, and I check my clusters here, There's a lot more here because, we have service discovery and stuff working in Glue, but what's important is to see the pet store one. And so this time, these are my clusters for pet store. And let's see if this is easier to show. So here's my cluster definition for pet store. But you'll notice that first of all, I have two different IP addresses. I have 10.244.0.10 and 244.0.20 and those are not the service IPs. So if I were to get my pods and I look at the IP addresses, you'll see that one of the pet store pods is 10.244.0.10 and 10.244.0.20, right? Those are what the endpoints are from the Envoy cluster perspective. Because now I have something that understands Kubernetes, that knows what pods like endpoints are. Really, if I were to do get endpoints, right? You see that pet store has these two endpoints, right? Because underneath the covers, Kubernetes knows, Kubernetes has a concept of endpoints. And so the control plane is watching for this and says, for the pet store service, these are the endpoints that you care about. And so now I can do, layer 7 stuff that, I want to send 5% of all requests to 244.0.20 versus 0.10. So it's a little quick, but under the covers, this is how Istio works, this is how Glue works, this is how you make Envoy work for you in kind of the cloud native microservices world. So I'll stop there. We only have 5 minutes left. If there are any questions, I'm definitely happy to talk through it. I'm happy to go a little longer as well if we need to. So I'll go ahead and stop there.
All right, I'm sure everybody's on mute is the only reason you can't hear anybody cheering with applause. That was great, Lawrence. Thank you. I really, really liked how you actually started with a bare Envoy config because, coming from a company that's implemented Istio, I think, and even to myself, I think, people can put their hands around the configuration service that Istio exposes. But then, when they think they've got that YAML right and Envoy's not doing, or Istio in general is not doing what they think it is, they often will go hit that admin panel and they'll look at the config and it's just like, oh my gosh, because with service, discovery and having hundreds or thousands of pods in a particular cluster, I mean, it's like, the 10,000 lines of config in a single pod or a single sidecar, and it can be really, really difficult to understand. Do you have any other tips for people who are either developers or operators who are getting interested in this space or interested in deploying these to get to a higher level of confidence about really knowing what's going on under the covers and being able to troubleshoot below kind of the control plane?
Yeah, so I think you really hit on it. Using Istio or using any kind of Envoy-based tool, I think if you want to be kind of a power user or operator or whatever, really understanding what Envoy is actually doing is pretty important. These tools are meant to abstract Envoy for you, but if you're on the hook for supporting something like this, it doesn't. There's no reason that you don't want to go a little bit deeper and understand what's actually happening under the covers. As far as recommendations, I really think that understanding. So if we go back, like understanding how, and you don't have to go super in depth, but understanding how to configure Envoy with the raw config, I think is really one of the most useful things that I've done. And then you could even use something as a jumping off point. So Istio maybe is a little, there's a lot there. Glue is a little less complicated, and whatever you end up doing. But seeing how tools like that, they ultimately generate Envoy config, right? And so kind of reverse engineering from that Envoy config to understand what's actually happening inside of Envoy really helps. That's one of the things that I did a lot. And then really getting familiar with the Envoy documentation. At least at first, I was not too impressed. But once I actually started understanding how Envoy works, the documentation actually helps a lot. Because ultimately, what we're looking at in this config, right, the API for Envoy is based on protobufs. And so ultimately, what you're doing is you're configuring a bunch of the fields in the messages for the various API types. And so let me see. I actually think I still have it up. So once you know how to tie, so like, okay, for example, we have a filter chain here, right? So we have static resources, and then in the listener, we have a filter chain. And then knowing how to tie that back to the Envoy config over here. So here's the listener filter chain, right? And so knowing how to jump back and forth between, the config and then the API, the protobufs, really helps a lot, because then you can see how they map together and what they actually mean. And kind of you can start kind of deconstructing, okay, given this Envoy config, let me go and see what actually all of these fields really do mean. And so that, and then Honestly, I've started to kind of go through the Envoy code. Given that it's C++ and it's a pretty beast of a project, that's not necessarily the easiest way to do it. But I think even just kind of getting that exposure will help, because once you start understanding what, for example, the HTTP connection manager is doing, right, it makes your job as an end user much easier. Because even if you have like a slight idea of what's happening under the covers, it really helps you think through, okay, if I need to troubleshoot something, okay, this is what the connection manager is doing. Let me go through the logs and et cetera. And then, yeah, one last thing, actually, the debug logs in Envoy are actually really useful. So having your logs set to debug and kind of watching a flow as it goes through all of your filters and everything also kind of gives you pointers of, okay, at this point in the flow, I'm in the connection manager. Let me go see what's happening there. And that's pretty much it, yeah. Brandon, I think you're on mute.
Sorry, very cool. Yeah, I was just asking other questions. I've definitely got other questions about this space, but I want to open up to the audience as well. Okay, I guess another question, just from Solo's perspective, right? I mean, there's a lot of different, service meshes out there. Some of them are purely open source. Some of them are kind of open, but, you can get commercial support. And then it seems like some people are also offering, open source core, but then kind of premium features that you can license on top of that. So can you talk a little bit about how maybe Solo sees the space, and how are you trying to position, your open source software, and are you bringing extra features into like an enterprise product, or is it just a support-based, revenue model? Like what does that look like for Solo?
So to the first part, there are definitely a lot of service meshes, and that's kind of one of the things, like choosing the right one is going to be difficult. And what I think we're kind of seeing is that Istio is definitely the most popular. But the thing about Istio is, if you want to use community Istio, like you mentioned, you more than likely are going to want support of some form for that. But so some folks that are running, they're more willing to spend engineering time and effort in running their own Kubernetes. Those are the kind of the folks that we see also willing to run their own Istio. On the other hand, if you're running everything in AWS, it would make complete sense to, okay, let's just use AWS App Mesh, right? Because we get the benefits of the service mesh. We also get an Envoy-based service mesh, but it's something that's in line with the rest of our environment, right? The rest of our stuff. And then I'm sure Azure and Open Service Mesh will be similar. So I think what we see is kind of that. And so you'll see, and then if you have folks that are say, okay, let's do on-prem and AWS, it would make sense. And we're kind of having a discussion with folks like, do they want to run Istio in their on-prem and then run App Mesh in their AWS environment? And that's where Service Mesh Hub, we didn't spend a lot of time talking about it, but that's kind of what we're positioning as the next step is, for folks that are in that kind of hybrid world, having a tool that can kind of, make it easier to use both of them at the same time. That's where something like Service Mesh Hub comes into play. And so right now, Service Mesh Hub is open source. There will be an enterprise offering built on top of it that will be releasing sometime soon. But ultimately, yeah, that's kind of where we see Service Mesh Hub coming into play. And what we do, we think at least that there will be people, probably a lot of people, that have more than one service mesh in play, just because of the nature of, if you're running in AWS or if you're running in Azure, you probably want to use the native tooling there. And if you're not, then community Istio makes sense or something like that.
Very cool. Do you see a lot of customers doing multi-cluster mesh today?
So I think that's starting to grow. And I think the main use case that we see for it starting to grow is the HA reason. And so a lot, if you're going to be running multiple clusters for redundancy for HA, and one of those, and if you're using a service mesh, you're going to need multiple service meshes, right? Because you're going to have, if you're doing a proper replica, right, you want them to be the same. So you want service mesh A or cluster A to have the same service mesh as cluster B. And so when you're talking about failover, I think I closed the slides, but one of the interesting things that will happen there now is, how do I perform failover? Because if you have a cluster A and cluster A prime, in east and west, if some service goes down in that mesh, do you really want to fail over all of your traffic to the other cluster just for a single service, right? And so that's where things like, what we see happening is, that's what's really driving the use case for the multi-cluster. It's not necessarily that you want to have, multiple different meshes combined. Although that is a use case, I think the most pressing real world problem is how do I handle failover between different services, or I guess the same services in different meshes?
Gotcha. Yeah, that makes perfect sense. All right. Any other questions for Lawrence? We're a little bit over, but take another question if anybody has one.
Lawrence, this is great. Thank you.
Absolutely. Thank you. Thanks everyone for attending.
All right. Well, yeah, like I showed in the beginning, if you want to learn more about Solo, you can go to solo.io. Otherwise, I'm sure if you have more questions about what Lawrence talked about here today, they also have a Slack channel. So go ahead and seek that out if you're looking for some more tips, tricks, or advice on Service Mesh. But really, again, I want to thank Solo and thank Lawrence Gadban for coming in and talking with us today. This was really interesting. We really thank you.
Absolutely. My pleasure.
All right. Thanks,
Take care.
everybody.